Hello, my name is Zhao Wei. This is the project for my pattern recognition and intelligence course. My project title is Pattern Recognition Implementation in Face Recognition. I use MATLAB as a language tool. So, the problem under study is, you may ask, what is face recognition? Well, face recognition is defined as establishing the person's identity based on facial characteristics. In its simplest form, the problem of face recognition involves comparing two face images and determine if they are of the same person. And the third point is, humans are good at determining the similarity between two faces images acquired under diverse conditions. However, automatic face recognition has several challenges because it's hard for the computer to distinguish two different people, different genders, different face color. The psychology of face recognition is based on the observations that humans can recognize characters and cartoon faces. It is inferred that humans perceive the face based on certain higher level characteristics. And the second point is, studies using advanced brain imaging techniques such as function magnetic resonance images are expected to reveal the precise face processing mechanism in the human brain. And there are four methods using in face recognition. The first one is appearance-based methods. This method uses classifiers that operate directly on the normalized pixel intensity of the image without attempting to extract or change the facial features. The second method is rule-based methods. This method employs knowledge of the components of the face, for example, their eyes, nose, and the mouth, and their relationships with these different features. The third method is feature-based methods. This method uses grouping of edges, skin color, shape from shading, template, matching methods. The last one method is texture-based methods. This method uses texture features to represent and detect facial patterns. Now, introduce this face recognition method. The simplest approach is to think of it as a template matching problem. This is m multiple by n image, and you can stretch it into a n square vector. The problems would arise when performing recognition in a high-dimensional space. So, how to find this lower dimensional space? I'm going to talk about the main ideas behind these eigenfaces. Suppose that the gamma here is an n square vector, which represents this one, and corresponding to n multiple by n face image I. The idea is to represent gamma phi equals gamma minus mean face into a low dimensional space. The function is here. So what's the steps of this method? let's come to the computation of the eigenfaces part. You can obtain face images IE, I2 to IM. This is the training phases. You must remember, it's very important. The face images you get from internet or your phones, whatever, they must be centered and of the same size. Otherwise, you cannot use this as the training phases. Or you can convert it or enlarge or smaller the image before use. The second step is to represent every image I as a vector gamma I. And the third step is compute the average phase vector. Here, this is the equation. 4. Subtract the mean phase. The fifth step is to compute the covariance matrix C. Compute the eigenvectors Ui of. So the AA, this is convert matrix of A. Since it's very large, it's not practical. So you have to follow these 3 steps. Now I'm gonna show you come to the last part and show you how to operate on MATLAB hand in hand. So if you run the first program, you will get the eigenfaces. Oh no, why it's not show up? Okay, you can run afterwards. This one, I think they will show the C. Yes, this is eigenfaces. I think this will show the last result. Last result of CMC rank 1 recognition rate. Okay, you can see the graph from my final report on you can see from at one number of utilized features that the recognition rate no longer increase. That's roughly at number 83. It's a long program. Okay, so my conclusion is that the eigenfaces approach to face recognition. This approach was motivated by or enhanced by information theory, leading to the idea of basing face recognition on a small set of images of features that best approximates the set of known face images without requiring that they respond to our intuitive notions of facial parts and features. Although it is not an elegant solution to the general recognition problem, the eigenface approach does provide a practical solution that is well fitted to the problem of face recognition. It is fast relatively simple and has to be shown to work well in a constrained environment. It can also be implemented using modules of connectionless or neural networks. So this is my conclusion. Thank you.